Welcome student to my YouTube channel Bharat Chem Study. Today we are going to study about basic concept of chemistry 4 plus 1 class. In this video part 3 we are going to study about laws of chemical combinations, their definitions and numerical based on them. So let's start with the topics. Law of chemical combination. The first law of conservation of mass. It states that in a chemical reaction the total mass of the product is equal to the total mass of the reactant used, or we can say matter can neither be created nor be destroyed. Let's take an example. In this equation, hydrogen reacts with oxygen to give water. Suppose 4 gram of hydrogen reacts with 32 gram of oxygen and the product form is 36 grams. The sum of the masses of the reactant is equal to 4 plus 32 is equal to 36, which is equal to the mass of the product form. So we can say in this equation the law of conservation of mass is followed. Chemical equations need to be balanced in order to satisfy this law of conservation of mass. Let's do a numerical. In a chemical reaction, 5.3 gram of sodium carbonate and 6 gram of ethanoic acid react to form 8.2 gram of sodium ethonate and 0.9 gram of water and 2.2 gram of carbon dioxide. Show that the given data is in agreement with law of conservation of mass. So here the mass of the reactants are given and the mass of the products are given. So here a hint. If we are not knowing the chemical formula, we can use the name of the reactants as well as product to solve our numerical. So let's do the solution of this numerical. So here is the equation according to the question, that sodium carbonate, which is 5.3 gram, react with ethanoic acid, which is 6 gram, to give sodium ethonate 8.2 grams, water 0.9 grams and carbon dioxide 2.2 grams. Here we have to show that the given data is in agreement with the law of conservation of mass, and that will be possible only if the sum of the masses of the reactant is coming equal to the sum of the masses of the product. So here the total sum of mass of all the reactant is equal to 5.3 plus 6 is equal to 11.3 grams, and the total masses of all the products is equal to 8.2 plus 0.9 plus 2.2 is also coming to be 11.3 grams. So since the total mass of the reactants is equal to total mass of the products form, hence we can say the given data is in agreement with law of conservation of mass. Now the next law is law of constant composition or definite proportion. It states that a chemical compound is always found to be made up of the same element combined together in a same fixed ratio by mass. For example, in carbon dioxide, always carbon and oxygen are present and they are present in ratio 12.32 by mass. If the ratio of carbon and oxygen is going to be changed, then carbon dioxide will not form, some other compound may be formed. Similarly, in water, only hydrogen and oxygen are present and hydrogen and oxygen are present in 1 ratio each by mass. Let's do a numerical. So please understand this. In this numericals, 2 experiments was carried out. In both experiment, copper is formed. In first experiment, copper was formed by reducing copper oxide, and in another experiment, copper is first converted to nitrate and then converted to oxide, and the oxide containing the copper is given. So to show that this data illustrates the law of constant composition, we have to show that in both the experiment, the amount of the percentage of copper present in the copper oxide is same. So how we have to solve the numerical? Let's see that. In first experiment, copper oxide was given 1.375 gram and copper left is 1.098%. That means the percentage of copper in the copper oxide in the first experiment is calculated as weight of the copper multiplied by 100 divided by weight of copper oxide. On putting the value, the answer is coming equal to 79.8%. In second experiment, the copper was taken 1.179 grams and the copper oxide formed is 1.476 gram. Therefore, the percentage of copper in the copper oxide of second experiment is 1.179 into 100 divided by 1.476, and which is equal to 79.8%. So in both these experiments, the percentage of copper in the copper oxides are same. Therefore, we can say that the copper oxides are also same. Since the percentage of copper oxide in both the experiment is same, therefore the given data illustrate the law of constant composition. They contain same amount of copper, that means they also contain same amount of oxygen. So here another experiment in which 6.4 gram of lead combined directly with 1.002 gram of oxygen to form lead peroxide. The lead peroxide is also produced by heating lead nitrate, and it is found that the percentage of oxygen present in lead peroxide is 13.38%. Use this data to illustrate the law of constant composition. Again, here two experiments are carried out to prepare lead oxide. So again, if we are able to find out the percentage of either lead or oxygen in both the experiment, and if the percentage come to the same, then the given data illustrate the law of constant composition. It can be done in two ways. Either we can calculate the percentage of oxygen in both the peroxides, or we can calculate the percentage of lead in both the peroxides. So here in second experiment, the percentage of oxygen is given. Therefore, in the first experiment also we have to calculate the percentage of oxygen. Let's solve that. In the first experiment, the weight of lead is equal to 6.448 grams and the weight of oxygen is 1.002 grams. Since the weight of lead peroxide formed is 6.448 plus 1.002, because lead peroxide is formed by the combination of lead and oxygen, it comes to be 7.490 gram. So in this experiment, percentage of oxygen is already given in the second experiment. Therefore, in the first experiment also, we are going to calculate the percentage of oxygen present in the lead peroxide, which is equal to 1.002, that is weight of oxygen multiplied by 100 divided by the weight of lead peroxide, and answer is come to be 13.38. This percentage of oxygen in the first experiment is equal to the percentage of oxygen present in the lead peroxide of second experiment. Therefore, we can say the given data illustrate the law of constant composition. The law of multiple proportion, it states that when two elements combine to form two or more chemical compounds, then the mass of one of the element which combine with the fixed mass of the another bear a simple ratio to one another. It is difficult to understand topic by definition, so let's take an example to understand this. For example, carbon combined with oxygen to form two compounds, carbon dioxide and carbon monoxide. So let's see that carbon reacts with 12 gram of carbon reacts with 32 gram of oxygen to give carbon dioxide, and 12 gram of carbon reacts with 16 gram of oxygen to give carbon monoxide. Thus, the mass of the carbon here in both experiments is fixed, that is same. Thus, mass of oxygen atom which combined with fixed mass of carbon, that is of 12 gram in carbon monoxide and carbon dioxide, is 16:32, that is the ratio is come to be 1:2, which is a simple ratio. Hence, we can say the law of multiple proportion is satisfied. So, in the numerical of law of multiple proportion, we have to fix the mass of the same atom in both the equations, and then the mass of the another atom, the ratio of those masses must be taken. If it comes to be simple whole number ratio, then law of multiple proportion is followed. Let's understand with one numerical. The carbon is found to form two oxides which contain 42.9% of and 27.3% of carbon respectively. Show that these figures illustrate the law of multiple proportion. So here two experiments was given and two oxides are formed. They are not telling us which oxide is carbon dioxide, which oxide is carbon monoxide. So we take the oxide 1 and oxide 2 as the solution can be done. In first experiment, carbon plus oxygen give first oxide in which the carbon having weight 42.9 grams. Percentage means can convert into grams out of 100. So the carbon percentage become 42.9 gram and the remaining part is oxygen, which can be calculated by subtracting 42.9 from 100, because the value is given in percentage. So we can subtract from 100 to get the weight of oxygen here. From the equation, it is clear that for the formation of first oxide, 42.9 gram of carbon combined with oxygen, that is 57.1 gram. So here we are going to fix the mass of carbon atom, which is better to make it 1 gram. Therefore, 1 gram of carbon combined with hydrogen to form the first oxide will be calculated as 57.1 divided by 42.9, which is come to be 1.33 gram. So here we make the mass of the carbon atom 1 gram, and 1 gram of carbon required 1.33 gram of oxygen to form the first oxide. Similarly, in the second experiment, the carbon 27.3 grams react with oxygen. Mass can be calculated by subtracting 27.3 from 100 gives second oxide. So from the equation, it is clear that 27.3 gram of carbon combined with oxygen is equal to 72.7 gram. Therefore, 1 gram of carbon require oxygen to form the second oxide is equal to 72.7 divided by 27.3, which is equal to 2.6 gram. So in these numerical, we are fixing the mass of carbon to 1 gram and the remaining mass of oxygen in both the experiments, which are reacting with 1 gram of carbon. Therefore, the ratio of oxygen which combined with fixed mass of carbon is 1.33 ratio 2.66, which is come to be simplified that 1:2. Since this is a simple whole number ratio, So the above data illustrate the law of multiple proportion. So what we understand from the numerical, that in this numerical two equations are given in which the rectangles are same but the product is different, and to satisfy this law for the calculation of this numerical, we have to fix the mass of any one of the rectangles which is common in both the equations, and according to that the remaining part of the second rectangle, their ratio has to be taken, and that ratio must become in whole number ratio. Let's do one more numerical to show the law of multiple proportion. 3 oxides of lead are analyzed to be found containing lead as under: 3.45 gram of yellow oxide contain 3.21 gram of lead, 1.195 gram of brown oxide contain 1.035 gram of lead, 1.77 gram of red oxide contain 1.61 gram of lead. Show that the given data illustrate the law of multiple proportion. See clearly this numerical, the product is lead oxide. Yellow oxide, brown oxide and red oxide, all these have the different formula, but the reactants are same, lead and oxygen. That means they are formed by the reaction of lead and oxygen. So all these experiments, the weight of the product and the weight of the lead is given, and the weight of the oxygen has to be calculated by subtracting the weight of lead from the weight of the metal oxide. So let's do that. How to do the numerical? So in the first experiment, lead plus oxygen give rise to yellow oxide. Here weight of lead is given 3.21 gram and weight of yellow oxide is given 3.45 gram. So by subtracting the weight of lead from yellow oxide, we can easily find out the weight of oxygen like yellow oxide. Similarly, in the second experiment, lead plus oxygen give rise to brown oxide. Weight of the lead is given and the weight of the brown oxide is also given. So by subtracting it from the weight of lead from it, we can get the weight of oxygen. In the third experiment, weight of red oxide is given and the weight of lead is given. So by subtracting the weight of lead from red oxide, the weight of oxygen can be calculated. So all these three equations, the rectangle lead are common and the second rectangle oxygen are common. So to illustrate the law of multiple proportion, we have to fix the mass of either lead in all the equation or oxygen in all the equation, and the remaining weight which is coming for the another rectangles which are combined with the fixed mass of the rectangle one, their ratio has to be taken. So let's take in yellow oxide 3.21 gram of lead combined with oxygen is equal to 0.24 gram. So 1 gram of lead combined with oxygen is equal to 0.24 divided by 3.21 and is equal to 0.075. So in this experiment, we are going to fix the mass of lead as 1 and we have to calculate the mass of oxygen which are going to combine with 1 gram of lead. Similarly, in brown oxide, that is second experiment, 1.035 gram of lead combined with oxygen is equal to 0.16 gram. So 1 gram of lead combined with oxygen is equal to 0.15 gram for brown oxide. In red oxide, 1.6 gram of lead combined with oxygen is equal to 0.16 gram. So that means 1 gram of lead combined with oxygen to form red oxide is equal to 0.10 gram. So here in all these three experiments, the weight of the lead is fixed to 1 gram and according to 1 gram, the weight of oxygen has to be calculated. Now we have to take the ratio of the oxygen from all three experiments which are going to combine with fixed mass, that is 1 gram of lead, and the ratio is come to be 0.075, ratio 0.15, ratio 0.10. Now let's simplify it into a simple whole number. For that, first of all we divide all these by 1000 to remove the decimal place, and then we multiply all the numbers with 1000 and the ratio will come to be 75, ratio 150 and 100. Now we take out the common factor in all these values. 25 is the common factor. So on removing the common factor, the ratio is come to be 3 ratio 6 ratio 4, which is a simple whole number ratio. Hence we can see the given data illustrate the law of multiple proportion. One more numerical. A metal oxide forms two oxide. One contains 46.67% of metal and another contains 63.94% of metal. So percentage we can convert it to gram, and to calculate the mass of the remaining rectangle, we have to subtract the mass of the metal from 100. So here in this experiment, again we have to that this data is in agreement with law of multiple proportion. So this numerical you have to do yourself. I am providing the hint. The mass of the metal combined with 1 gram of oxygen is coming to 0.87 gram and 1.773 gram. The ratio is come to be 1:2. So again in both these experiment, the mass of the metal is given, the mass of the oxygen you can calculate by subtracting this given mass from 100, and again you have to fix the mass of either metal to 1 gram or mass of oxygen to 1 gram. The amount of oxygen has to be calculated according to 1 gram, and then we have to take the ratio as in the previous numericals. The law of reciprocal proportion. When two elements combine separately with a fixed mass of a third element, then the ratio of their mass in which they do so is either the same or some whole number multiple of the ratio in which they combine with each other. So again, this is very difficult to understand from the definition, so we have to take the examples. In law of reciprocation, three different reactants are given and three different products are formed. For example, the element carbon, oxygen combine separately with hydrogen to form methane and water, and when carbon and oxygen combine with each other, they will form carbon dioxide. So if carbon reacts with hydrogen, it gives methane, oxygen reacts with hydrogen, it gives water, and carbon reacts with oxygen, gives carbon dioxide. So three equations are given. So first of all, we have to take any two equations with common reactant. So to do the numerical, in these equations, common reactants are hydrogen. So we are going to fix the mass of hydrogen here. In both equations, the mass of hydrogen are 4 grams. That means their mass is fixed. So we have to take the ratio of the carbon and oxygen which are going to combine with fixed mass of hydrogen. The ratio is come to be 12 ratio 32, that is 3 ratio 8, and this is the first ratio. And when they combine with each other, that is carbon and oxygen, when combined with each other, we also have to calculate their ratio. The ratio is also coming 12 ratio 32, that is 3 ratio 8. So that means the ratio of the masses of the different elements which are combined with the fixed mass of one reactant, and when they combine with each other, that ratio either they are come to be same or come to be some whole number multiple. So in methane, 12 part of carbon combined with 4 part of hydrogen, and in water 4 part of hydrogen combined with 32 part of oxygen. Therefore the ratio of carbon and oxygen come to be 12 ratio 32, that means 3 ratio 8, and when carbon and oxygen combine with each other, again the ratio is come to be 3 ratio 8, and since the ratio is come to be same, therefore we can say that law of reciprocation is followed. Let's take one more example to understand it more clearly. Carbon dioxide contains 27.27% of carbon, carbon disulfide contains 57.79% of carbon, and sulfur dioxide contains 50% of sulfur. All these figures are in agreement with law of reciprocal proportion that we have to show. So again here three different products are given. So let's make the equation for them first. So in carbon dioxide, carbon and oxygen combine to give carbon dioxide, and the percentage of carbon is given 27.27 grams. So the total mass of the carbon dioxide taken as 100. The weight of carbon is come to be 27.27, and the weight of calculate the weight of oxygen, we can subtract 27.27 from the weight of carbon dioxide, that is 100, and the values come to be 72.73%. Let's make the equation for the second product, that is carbon disulfide. In carbon disulfide, carbon reacts with sulfur to form carbon disulfide. The weight of this carbon is given as 15.79%. So that means to calculate the weight of sulfur, we have to subtract the weight of carbon from 100, and the weight of sulfur is come to be 84.21%. Now let's make the third equation. In the third equation, the sulfur dioxide is the product which can be formed by the reaction of sulfur with oxygen, and here the weight of sulfur is 50%, that is 50 gram out of 100, and the remaining oxygen must also be 100 by subtracting, and the weight of oxygen must also be equal to 50 by subtracting this weight of sulfur from 100. So these are the three equations. So in carbon dioxide, 27.27 gram of carbon combined with oxygen is 72.73 grams. So 1 gram of carbon, we are going to fix the mass. 1 gram of carbon combined with oxygen is equal to 72.73 divided by 27.27, which is come to be equal to 2.67. Similarly, in carbon disulfide, 15.79 gram of carbon combined with sulfur is equal to 84.21. So therefore 1 gram of carbon combined with sulfur is equal to 5.33 grams. So here now we have fixed the mass of carbon to 1 gram, and the mass of oxygen in first compound and the mass of oxygen in second compound as calculated. So the ratio of the oxygen and sulfur which are going to combine with the fixed mass of carbon, that is 1 gram, is come to be 1:2. Now We have to calculate the ratio of oxygen and sulfur when they combine with each other, form sulfur dioxide, and the ratio is come to be 1:1. So we have to divide the ratio of take the first ratio by the second ratio, and the answer is come to be 1:2, which is a simple whole number ratio. So given data is in agreement with the law of multiplication. So let's do one more numerical. In this numerical, H2S contain 94.11% of sulfur, water contain 11.11% of hydrogen, and sulfur dioxide contain 50% of oxygen. So in this numerical, three different products are given. That means law of reciprocation has to be followed. So let's write the equation for them. So for H2S is formed by the reaction of hydrogen and sulfur, and the mass of hydrogen and sulfur can be calculated. Mass of sulfur is given in percentage, therefore we can take the mass of sulfur as 94.11%, and the mass of hydrogen can be calculated by subtracting the mass of sulfur from 100, which is come to be 5.89 in H2S. In water, the weight of hydrogen is given 11.11%, so the weight of oxygen can be calculated by subtracting from the weight of hydrogen from 100, and the weight of oxygen is come to be 88.89. In the third equation, that is sulfur plus oxygen given as sulfur dioxide, the weight of the sulfur can be calculated by subtracting the weight of oxygen, which is 50 from 100, and it come to be 50 and 50 grams. Now in H2S, now again we have to take the two equations. The two reactants are common. So in this equation we are taking H2S and H2O, in which hydrogen is common, and the weight of sulfur and oxygen has to be calculated, which are going to combine with fixed mass of hydrogen. So let's make the mass of hydrogen in H2S 1 gram, and we have to calculate how much sulfur is required for 1 gram of hydrogen. So in H2S, 5.89 gram of hydrogen combined with sulfur is equal to 94.11. Therefore, 1 gram of hydrogen combined with sulfur is equal to 94.11 divided by 5.89, which is come to be equal to 16 gram. In water, 11.11 gram of hydrogen combined with oxygen is equal to 88.89. Therefore, 1 gram of hydrogen combined with oxygen is equal to 88.89 divided by 11.11 is equal to 8 grams. So now here we have fixed the mass of hydrogen in both the equation 1 gram, and the mass of remaining reactant, that is sulfur and oxygen, is calculated. Now we have going to take the ratio of this sulfur and oxygen, which is going to combine with fixed ratio of hydrogen, and the ratio is come to be 2:1. Always remember, here we have taken the mass of sulfur first and the mass of oxygen second, and when the sulfur and oxygen combine with each other, the ratio of the masses is 50:50 is equal to 1:1. Always remember, in the first ratio we have taken the value of sulfur first and then oxygen, and for the second ratio again we have to write the value of sulfur first and the value of oxygen later. So on dividing the first value ratio by the second ratio, the common ratio is come to be 2:1, which is a simple whole number ratio. Hence we can see the given data is in agreement with law of reciprocal proportion. Always remember that most of the numerical, 95% numerical, the law of chemical combination is always followed. Now, Gay-Lussac law of gaseous volume. When gases react together, they always do so in volume, which bear a simple ratio to one another and to the volume of the product if the product is gases under similar condition of temperature and pressure. This law we also have studied in our standard 10th. Avogadro law. It states that equal volume of all gases under similar condition of temperature and pressure contain equal number of molecules. That also we have studied in standard 10. At STP, that is the condition of 1 atmosphere pressure and 0 degree Celsius of temperature, 1 mole of a gas always occupied 22.4 liter of volume. A numerical based on Gay-Lussac law, that also we have studied in standard 10 standard, but let's recapitulate it. Numerical 1. What volume of oxygen would be required to burn completely 200 ml of acetylene, that is C2H2, and what would be the volume of the carbon dioxide formed? Always remember the Gay-Lussac law for combining volume is applicable for gases only. Solution. The equation can be written as this one, and whenever we are going to write equation ourselves or equation is given, always check the equation is balanced or not. If the equation not balanced, you are not able to do the correct numerical. So here on balancing the equation, we had found that 2 molecules of C2H2, that is acetylene, combined with 5 molecules of oxygen to give 4 molecules of carbon dioxide and water, 2 molecules of water in liquid form. When water is taken in liquid, the volume of water is not counted. So, according to the Gay-Lussac law from the equation, 2 volume of C2H2 react with 5 volume of oxygen to give 4 volume of carbon dioxide. According to Gay-Lussac law, it is clear from the equation. Now, weight volume of acetylene is given, so we have to calculate the volume of carbon dioxide from the volume of acetylene. So, according to the equation, 2 volume of acetylene require oxygen is equal to 5 volume. Therefore, 1 volume of acetylene require oxygen is equal to 5 by 2. Therefore, 200 ml of acetylene require oxygen is equal to 5 by 2 multiplied by 100, which is come equal to 500 ml. Now, for carbon dioxide, again from acetylene, 2 volume of acetylene produce carbon dioxide is equal to 4 volume. It is clear from the equation. Therefore, 1 volume of acetylene produce carbon dioxide is equal to 4 by 2 is equal to 2 ml is equal to 2. And now, that's for 200 ml of acetylene produce carbon dioxide is equal to 2 into 200 is equal to 400 ml. So, from the Gay-Lussac law, we have found that 200 ml of acetylene on burning require 500 ml oxygen and produce 400 ml of carbon dioxide. So, let's do one more example. 200 centimeter cube of hydrogen and 150 centimeter cube of oxygen are mixed and ignited as per following reaction. In this numerical, the equation is already given and it is balanced. What volume of oxygen remains unreacted? Because water we have to take in liquid form, so its volume is not counted. So the equation is this, and I got to give its flow 2 volume of hydrogen react with 1 volume of oxygen to give water whose volume is not to be considered because it is taken as liquid. So according to the equation, 2 volume of hydrogen use oxygen to 1 volume. Therefore, 1 volume of hydrogen required oxygen is equal to half volume, and 200 centimeter cube of hydrogen required oxygen is equal to half into 200, that means 100 centimeter cube. So from this, it is clear that 200 centimeter hydrogen require only 100 centimeter cube of oxygen, but the oxygen is given is 150 centimeter cube. Therefore, the amount of oxygen remain unreacted can be calculated by subtracting the amount of oxygen used by the amount of oxygen given, that is 150 centimeter cube minus 100 centimeter cube is equal to 50 centimeter cube. So, by solving the numerical, we have found that the 200 centimeter cube of hydrogen require only 100 centimeter cube of oxygen, and 50 centimeter cube of oxygen remain unreacted. Limiting reagent. The reactant which completely used up first in the reaction is called limiting reagent. In the above reaction, hydrogen gets used up and oxygen still remain unreacted. Therefore, we can say an above equation because hydrogen first finished. Therefore, hydrogen is act as a limiting reagent. Numerical third, 80 centimeter cube of methane is mixed with 200 centimeter cube of pure oxygen at the same temperature and pressure. The mixture is ignited. Calculate the composition of resulting mixture. When this line is written composition resulting mixture, that means we have to find out the volume of the product form as well as the volume of the unreacted reactant. If it is cooled to initial room temperature, so the equation is given. In this equation, the water is given a liquid form, therefore we are not going to take its volume. So according to this equation, first of all we have to check the equation is balanced or not. Here in this equation is balanced, and according to Gay-Lussac law, 1 volume of methane reacts with 2 volume of oxygen to give 1 volume of carbon dioxide. Now the weight of the methane is given 80 centimeter cube, so we find out that 80 centimeter cube of methane require how much oxygen and it will produce how much of carbon dioxide. So according to Gay-Lussac law, 1 volume methane require oxygen to 2 volume, and therefore 80 centimeter cube of methane require oxygen is equal to 82 equal to 160 centimeter cube. For carbon dioxide, 1 volume of methane produce carbon dioxide is 1 volume, therefore 80 centimeter cube of methane produce carbon dioxide is equal to 80 centimeter cube. Now for the unreacted oxygen, we have seen that oxygen is given at 200 centimeter cube, but the oxygen required by methane is only 160 centimeter cube. Therefore, the remaining volume of remaining oxygen is equal to 200 centimeter cube minus 160 equal to 40 centimeter cube, and the carbon dioxide form is 80 centimeter cube. Hence, the composition of the gases mixture, that is product, is 80 centimeter cube and 40, that is remaining oxygen. This is called the composition of gases mixture, that means the amount of product form as well as the amount of unreacted reactants. study and definition the laws of chemical combinations and do practice of numerical based upon them. In next video we will study more concept, empirical and molecular formulas, numerical based upon them, stoichiometric calculation based upon calculation of mass and mass volume or volume relationship. Please like and subscribe the channel for the latest update. Thank you.